Hello. Hi, everybody. It's a pleasure to be here talking in the Frontend Connect. So today I'm going to talk about our solution of micro-frontend. But before start, I'm going to present myself. So my name is Kai. I am from Barcelona. I am a native Catalan Spanish guy, even though you don't believe me. So I'm one of the front-end engineers from Adevinta central teams, as Corinne said. I've been working here, with this role for a lot of years. I joined this company like 3 years ago as a tech lead in CNT, where I've been implementing a monorepo solution. I had explained in the previous Frontend Connect. So when the project was done, I have changed to the team as an enabler in the Frontier. That is my current team, where I participated in many specific projects like a performance, Previt, Web Vitals, and now Micro-Frontends. I'm also well known as a guy who buy a tons of things that I don't really need. Like the last year, I decided to buy another TV when I already have a good one and a projector in my living room. So, well, so before I start, I want to introduce a bit the project that we are implementing this micro-frontend architecture and the reasons that why we decide on this. This project is called Serenity, and as Serenity team describes it, Serenity is a global and customizable moderation service. It enables marketplace to implement an automatic and manual workflows to detect behavioral fraud patterns within its local market. Serenity it's extensible and continuously evolving to support business needs. In a nutshell, it allows to the moderators to moderate our content our users post on our marketplaces. So let's talk about the needs. The marketplaces needs to optimize the dashboards that the moderators use. This is like a shaving seconds game. If we want to decrease the time that takes a moderator to review an ad, for example, from 90 seconds to 60 seconds at the scale, allows us to save a lot of resources and increase the operational efficiency. So, Subito, as one of our marketplaces, they require some changes in Serenity interface. But the thing is, currently, Serenity as architecture does not allow for this kind of customizations. So we were looking for a way to allow us for the tenants to inject their own functionality in Serenity. What do we want to achieve? So marketplace should be able to create and inject custom functionality in Serenity. Functionality from one marketplace should not conflict with the functionality from the coming another one. Sorry. Marketplace should be able to deploy and independent of each others, and we shouldn't have dependencies preventing from any marketplace from fully customizing its own dashboard. The code base should not be spaghettified, so we can just use a million of if statements trying to separate the code from the different marketplace. So we need a more robust architecture. So we decided to go with Webpack 5 and Module Federation solution. This is a relatively new technology that was released in March 2020. And we decided to be among of the early adopters. There are also another considerations that we push us towards Webpack. It is one of the most popular open source projects and the moment, and it will maintain for years to come. So in words of the creators of Model Federation, Model Federation allows a JavaScript application to dynamically run code from another bundle built on client and server. So with this idea, we started with a proof of concept. To make the conversation easy, we decided to name the Micro-Frontends the pieces of code encapsulated by the marketplaces with a specific functionality, in most cases, widgets. And the main application, the one that brings all the widgets together, it will be called container. Architecturally, the widget must be agnostic of each other. They will need to fetch their own data and render it. We will inject the context in them, such a current marketplace, login, permissions, and so on. So here I'm going to show you how our idea wants to show should be like in our mind. I don't know if you like Rick and Morty, but I guess everybody knows who are the Power Rangers. So every single robot are independent and they work without their partner, but they also can join together and became something more stronger. And they can kill like the monolith that could be represented here, like the villain. Okay, this is the funniest part. Sorry. So we applied the same solution as the other projects across the company for the main app or container. That is with Next.js as a framework, Slim, Cypress for the testing. We Dockerize the project and put an Nginx, and also we use Kubernetes, and all this managed by Travis. Like basically, like we extend this setup for many projects. So in the other side, for the widget side, we use a monorepo solution with Lerna and npm package, but we also included a new part, that is the deployment of the widget on a S3 bucket. So at this point, when everything was set up, we started to do some testing with a Hello World widget, and we crossed the fingers. And apparently, everything was working. We were super excited and super happy at that moment. Everything was working, but does it really? While the application was work with the simplest Hello World widget, once things became more complicated, the alarm bells start ringing. So we discovered that the Next.js and Model Federation aren't fully compatible at that time. I mean, we're talking about March of this year, maybe March, April. So I'm not sure now. So we discovered things like incompatibility of Next.js with the previous version, as I said. So there is a big context problem with the hooks, because the hooks are incompatible with the server-side generation. And basically, Next.js is based on server-side generation. I mean, server-side generation is the part when you have set up the Next.js before to set up the server-side rendering. So when you have both contexts, and when the server generates the front-end side, it generates a new context of React. So when you try to share the widget with the same package of React, they doesn't detect as the same, so they're gonna go with the different versions. So this is one of the main issues that we had, and we couldn't continue with this solution. So at this point, we had to roll back. We've been in the middle of a quarter, and the time was running out. So we decided quickly to move to Next.js with a native React application, because in our case, as this tool is, the nature of this tool is not, we don't need to have server-side generation or server-side rendering because it's a migration tool. It's an internal tool. Keeping all the things that we migrate the things, keeping all the things that we could and adapting all the changes. And after 2 weeks of work, we could migrate with the same project with the same picture as before, just removing Next.js. So at this point, we run the test again. And now, since the React hooks are working, we did 2 tests this time. One with the simple hello world with a simple hook, another one with a real widget with from the original application. At this point, we could say that everything works, at least for now. At least the migration of the widgets became more easier and transparent. We got less issues of compatibility across the libraries. So now let's zoom in a bit on details. Our future architecture, it will be designed based on widgets. This is the starting plan. However, as with any other project, we had to make small changes along the way and adapt it as we learn more about the Micro-Frontends and the project itself. So let's have a look. At we think the things should work. So for now, at least, imagine that we have our hardworking engineer coding a widget. Once he finished and he will create a pull request using a conventional commit, and once it's approved, it will check the difference between the master branch and the created PR. Once the difference has been detected, thanks to the conventional commits, it will generate a new version of the package. And it will publish the new tag with in Git and in a package in Artifactory. For all of this, we're gonna use Learn as a tool. So this is automated and self-managed, so it's very automated. And after this, we're gonna run like a post-publish script, and this will execute a bash command to publish the widget to an S3 bucket. Okay, the widget is another part of code. It's similar of the npm package, but it's like as a more Micro-Frontend federated widget. So at the end, we're gonna have this image from one of the package. So since the S3 doesn't have a semantic version control, in the shell script, we generate a folder with the version number and also another copy from the latest version. For the Artifactory, we don't need to do anything because the version control is auto-managed. So the S3 widget will be imported in the list of widgets in the container. Let's have a look at the code. In the end, that's the best way to understand how it works. So here is how it should look map import.js. This is the file that we import all the widgets in order to declare the container of the reference. So as you see, you have to import the widget one by one. For each one, you have to define the name to be used in the main application, like UI stop module in this case. And then we declare the defined name in the widget. So in this case, we put the same name. It's gonna be declared with the capitalized U. But this is how it works in your application, the container. And after the add in the same URL is the destination where is located the S3 bucket. So we grab each of the widgets in a high-order component. This allows us to easily use them inside the React application. It is in order to keep widgets agnostic from each other, and it will all widgets will be the same, get the same information with via props. So there's a reminder that the other widgets need to be defined in the React lazy function that let us render dynamic imports as a regular component. And once the widget is already defined, now we can import as a normal widget to our application. But in our case, we have to create a new high order component. The reason to make this is to have the components instance wrapped with all the environments, parameters declared, just to have the application cleaner. And here is how do you have to import in the application per se without needing to pass all the parameters. So clearly, here is how it runs in a page base. It is important to use the React suspend. In fact, it forces you to use it in order to indicate to React that this is not a part of the application itself. So in the case that it could fail, you have you can put another component, or you can put, like in this case, we put just loading the widget name. So, but what if we just want to customize an existing widget? Just some minor cosmetic changes that might speed up the moderators of a given marketplace. So let's get back to the school. So we base with the concept of object-oriented programming. Do you remember it? So let's simplify. Let's imagine that a simplified approach where each widget is a class. With object-oriented programming inheritance, we can extend from our original widget, override the method we want to change, and keep all the other functionality intact. So, sorry. So how would we apply this to our situation? So now the marketplace will do a similar process as we showed in the previously, but it will look in this way. They will create a new widget in the repository and import the existing one with jar. They're gonna adapt the functionality that they need, as we showed in the previous slide. And then they're gonna publish to their Artifactory. Once it's published, they're gonna run another post-publish script, and they're gonna upload to their own bucket to the model federation widget. So then we can aim to this from the container. So does it work? We hope so. At the moment, we are migrating Serenity to this new sorry, to this new architecture, one page at a time, with each page being one gigantic widget. This allows us to learn more about micro-frontends and refine the project as we go along. We are breaking the monolith, so to speak. So this is still under development, but we are confident that we will make it work. If you want to learn more about how the project evolves in the following month, please feel free to contact me or my team. So now I'm gonna show you a bit how it works. It's just like a image. So if we show this is a real scenario of the application. This is on pre-production. So if I refresh, you can see that most of the widgets we already migrated and it's working on pre-environment. The message mode is the only one that is still not working. This this menu it's auto-loaded and see if it works. So now I'm gonna show you this the console, and I will show you the networking, how does it work. So if you remember, all the widgets we call with a standard name, it's called remote entry. So if you see on the right side, the remote entry has been loaded. I don't know if you can read. I'm gonna zoom in a bit. So as you can see, here we are loading from the Serenity. So each of them is like, this one is the ads module, this is the decision list, this is a hello app. So this is the the rules module. And if you see, you can see also the response, and you have this is the variable that is defined on the name, etc. So, for example, those numbers are generated by the module federation, and it will it, let's. I mean, the bundle is not, they don't compile in a single file. They're split in depending of the size of your application, or well, in your widget in this case. So I think that's all. If you have any questions, it's your time.